You watch the barista's hands as she prepares your morning coffee. Her movements precise, economical, almost unconsciously graceful. She simultaneously responds to your question about the day's special blend, maintains eye contact, and perfectly times the pour of steaming water through the filter. Without realizing it, this multitasking barista might be displaying one of the subtle, unconscious behaviors that cognitive scientists have recently linked to higher intelligence. But what if intelligence isn't what we think it is? What if the standardized tests, the academic credentials, and the carefully constructed resumes tell us far less about cognitive capacity than the unconscious habits we display when we are not trying to appear smart? Imagine for a moment that your most automatic behaviors, the way you talk to yourself when alone, how you organize your living space, even how you respond to being interrupted, might reveal more about your intelligence than any deliberate demonstration of your knowledge ever could. These unconscious patterns, developed over decades of neural pruning and reinforcement, may constitute a kind of cognitive fingerprint that we leave behind in everything we do. The truly intelligent person leaves traces of their cognition everywhere, like footprints in the sand, says Dr. Nora Jensen, cognitive neuroscientist at the Massachusetts Institute of Technology. But because these traces manifest as habits rather than achievements, they often go unnoticed, even by the individuals themselves. In 2018, a landmark study at Stanford University upended conventional wisdom about intelligence markers. The researchers discovered that certain unconscious behaviors correlated more strongly with problem-solving ability, creativity, and emotional intelligence than did traditional IQ metrics. These findings sent shockwaves through the psychology community, challenging a century of intelligence testing methodology. Why does this matter? Because we have built entire systems, educational, professional, even social, around recognizing and rewarding certain visible manifestations of intelligence while potentially missing its deeper, more reliable indicators. The implications extend from how we hire and promote in the workplace to how we structure learning environments for the next generation. What follows is an exploration of 9 surprising unconscious habits that reveal intelligence according to the latest cognitive research, habits that you might recognize in others or perhaps in yourself. Some may seem counterintuitive. Others might validate what you have always suspected about the quiet person at the back of the room who speaks rarely, but whose words carry unexpected weight. The journey begins with understanding why our unconscious behaviors reveal more than our conscious presentations ever could. Consider the case of Patrick Griffith, a janitor at Princeton University who, for 3 years, solved complex mathematical equations anonymously left on classroom blackboards after hours. Professors had been posting these unsolved problems as challenges for graduate students. When finally discovered through security footage, Griffith revealed he had never completed college, but had been teaching himself advanced mathematics for decades. "I never thought about whether I was smart or not," Griffith explained in a 2019 interview. "I just liked solving puzzles." His case exemplifies how intelligence often manifests not in credentials or self-promotion, but in habits, in his case, the habit of persistent problem-solving regardless of external validation. Our brains, those remarkable 3-pound universes we carry in our skulls, operate largely beneath our conscious awareness. Neuroscientists estimate that approximately 95% of brain activity occurs beyond conscious thought. This means that the vast majority of what makes us intelligent happens automatically, in systems refined through evolution and experience to operate without the bottleneck of conscious processing. Dr. Elena Mikhailoff, neuropsychologist at Oxford University, explains, "Consciousness is actually a very limited resource. The most sophisticated cognitive processes are the ones that have become automated, allowing our conscious mind to focus on novel challenges while habituated patterns run in the background. And here lies our first clue. Truly intelligent people have automated more complex cognitive processes than others. Their unconscious habits reflect neural pathways that have been strengthened through repetition until they no longer require conscious effort. But what exactly are these telling habits? And how did scientists identify them? The story begins in an unexpected place, not in a laboratory, but in a series of open office environments across Silicon Valley, London, and Tokyo. In 2016, Dr. Jensen and her research team embarked on what they called the Unintentional Intelligence Project. Rather than relying on self-reported behaviors or controlled experimental tasks, they used an array of unobtrusive sensors, cameras, and microphones to capture the natural behaviors of over 2,000 professionals across various fields for 6 months. The subjects underwent comprehensive cognitive assessments, including not just IQ tests but evaluations of emotional intelligence, creative problem-solving, and practical intelligence, what psychologists call successful intelligence in real-world contexts. When the researchers analyzed the mountains of behavioral data against these cognitive measures, unexpected patterns emerged. The strongest correlations with high intelligence weren't found in the obvious places, not in vocabulary usage during presentations or even in the quality of work outputs, but in subtle, largely unconscious habits that subjects displayed when they thought no one was watching or evaluating them. What surprised us most, recalls Dr. Jensen, was that these intelligence signaling behaviors were almost entirely non-performative. They weren't things people did to appear intelligent. They were things they couldn't help doing because of how their brains naturally operate. This distinction is crucial. In social settings, humans frequently engage in what social psychologists call impression management, deliberately modifying behavior to create desired impressions. But the behaviors identified in Jensen's study were different. They persisted whether or not others were present to witness them. They were, in the truest sense, habits rather than performances. And this brings us to our first unconscious habit that reveals intelligence: the tendency to talk to oneself, out loud or internally, in fully formed questions rather than statements. Dr. Marcus Paulson, a cognitive psychologist who participated in Jensen's study, explains, "We found that individuals who scored in the top quartile for problem-solving consistently engaged in self-questioning rather than self-direction. Instead of saying to themselves, 'I need to figure this out,' they asked, 'How could I approach this?' The interrogative form activates different neural pathways than the declarative form. Neuroimaging studies have confirmed this distinction. When we pose questions to ourselves, we activate regions associated with open search and divergent thinking. By contrast, making statements to ourselves tends to reinforce existing neural patterns. This subtle difference in self-talk correlates strongly with cognitive flexibility, the ability to adapt thinking strategies to novel situations, a core component of intelligence. Consider the case of Nina Jacobson, a software engineer whose team at Google was tasked with solving a particularly thorny algorithm problem. Unaware that the research team's sensors were capturing her behavior, Jacobson was recorded pacing her office after hours, repeatedly asking herself variations of, "What am I missing here?" And "What would happen if we approached this from the opposite direction?" This self-questioning habit preceded her eventual breakthrough, a solution that later saved the company millions in computational costs. She was essentially using her self-talk to break her brain out of established patterns, explains Dr. Jensen. By formulating questions rather than statements, she was preventing premature cognitive closure, the tendency to settle on an answer before fully exploring the problem space. The second unconscious habit reveals itself in how highly intelligent people interact with new information. While most people display confirmation bias, the tendency to favor information that confirms existing beliefs, highly intelligent individuals unconsciously practice what researchers now call strategic confusion. This manifests as a momentary pause when encountering new information, especially information that conflicts with what they already believe. Instead of the normal human response of immediate acceptance or rejection, highly intelligent brains automatically suspend judgment, creating a cognitive space where contradiction can exist temporarily without resolution. Dr. Robert Chun of Stanford Center for Cognitive Analysis describes it as the willingness to be comfortably confused. In one revealing experiment, his team presented subjects with evidence that contradicted their political beliefs while scanning their brains using functional MRI. Those with higher measures of cognitive ability showed increased activity in the anterior cingulate cortex, a region associated with detecting errors and conflicts, but decreased activity in the amygdala, which processes emotional reactions to threats. Most people experience cognitive dissonance as emotional discomfort and rush to resolve it by rejecting the contradictory information, Chan explains. But the most intelligent brains have developed the habit of tolerating that dissonance long enough to process the new data more thoroughly. This habit manifests behaviorally as a characteristic pause before responding to surprising information. The research team coded thousands of hours of conversation, finding that this pause, typically lasting between 2 and 4 seconds, was strongly predictive of higher cognitive functioning across multiple domains. The third unconscious habit emerges in physical environments, specifically in how intelligent people organize their personal spaces. Contrary to the popular image of the messy genius, Jensen's research revealed a more nuanced reality. Highly intelligent people create environments with strategic order and productive disorder. We found a distinct pattern, explains environmental psychologist Dr. Sarah Winters, who analyzed the workspace data. High cognitive performers maintained meticulous organization for tools and resources they used regularly, while allowing apparent disorder in areas of ideation and creation. In practice, this means that the most intelligent subjects had precisely organized digital filing systems and immaculate collections of frequently used items, alongside seemingly chaotic piles of books, papers, or materials related to projects in active development. This dual approach wasn't a contradiction but a sophisticated adaptive strategy. The ordered elements minimize cognitive load for routine tasks, Winters explains, while the creative disorder maximizes unexpected connections between ideas, what we call serendipitous cognition. This finding connects to earlier research on creative cognition. A Cornell University study found that exposure to orderly environments promoted conventional thinking and charitable behavior, while disorderly environments stimulated creativity and unconventional problem-solving. The most intelligent participants in Jensen's study unconsciously created microenvironments that toggled between these states depending on the cognitive demands of different activities. But perhaps the most fascinating unconscious habit, the fourth on our list, appears in conversation dynamics. Highly intelligent people unconsciously create curiosity gaps in dialogue, intentionally leaving information incomplete in ways that prompt others to ask questions. It's not deliberate conversational strategy, clarifies Dr. Jensen. It's an unconscious habit that reflects how their brains naturally process information, in terms of connections and missing pieces rather than as discrete facts. In analyzing thousands of hours of recorded conversations, the research team found that individuals with higher cognitive flexibility scores consistently presented information with strategic omissions that generated natural questions from listeners. Rather than explicitly stating their entire thought process, they provided just enough information to draw others into collaborative thinking. Neurologically, this habit connects to the brain's prediction mechanisms. Intelligent brains continuously generate and test predictions about incoming information. When communicating, they unconsciously structure information to activate similar predictive processes in listeners' brains, essentially inviting others' neural machinery to engage with the problem. This particular habit illustrates a profound truth about intelligence. It is fundamentally social, even when expressed by individuals. The most intelligent brains have evolved to communicate in ways that recruit other brains into shared problem-solving. Intelligence doesn't exist in isolation, argues social neuroscientist Dr. Prakash Gupta. Even when we think alone, we're using cognitive tools developed through social interaction. The habits that signal intelligence often reveal this deeply social nature of cognition. The fifth unconscious habit manifests in how people respond to being interrupted. While most individuals react with annoyance or anxiety when their thought process is disrupted, those with higher cognitive capability display what researchers term fluid recovery. The ability to momentarily store their cognitive state, engage with the interruption, and then seamlessly return to their previous thought process. This ability correlates strongly with working memory capacity, a key component of intelligence. In practical terms, it appears as a distinctive three-phase response. A brief pause when interrupted, full attention to the interrupting matter, and then a characteristic retrieval gesture, often a slight tilting of the head, before continuing the original thought exactly where it left off. It's like watching someone place a mental bookmark, describes Dr. Jensen. They're not simply remembering what they were talking about, but retrieving their entire cognitive context, including tangential thoughts they hadn't yet expressed. Neuroscience offers an explanation for this phenomenon. The dorsolateral prefrontal cortex, an area critical for working memory and cognitive control, shows distinctive activation patterns in people who exhibit this fluid recovery habit. Their brains have essentially automated the process of context switching without losing information, a cognitive skill that underlies much of what we recognize as intelligent behavior. The sixth habit appears in how individuals process failure and mistakes. Through detailed analysis of facial expressions, body language, and subsequent behavior, Jensen's team identified what they called the immediate pivot response, a near-instantaneous shift from recognizing an error to treating it as an information source. This habit manifests as a characteristic micro-expression sequence, a flash of surprise or disappointment lasting less than half a second, immediately followed by heightened attention and engagement rather than defensive or emotional responses. Physiologically, the researchers observed decreased amygdala activation associated with threat response and increased activity in the brain's reward learning centers. The intelligent brain processes errors differently, explains neurologist Dr. Maria Liston. Where most people experience failure as a threat to self-image, triggering defensive responses, the highly intelligent brain has developed the habit of automatically categorizing errors as valuable data points. This habit reflects a neurological adaptation with profound implications. By processing failure as information rather than as personal threat, intelligent brains maintain cognitive resources that others lose to emotional processing. Additionally, they extract more learning value from each failure, accelerating their knowledge acquisition compared to peers of similar but less adaptively wired intelligence. The research team documented this habit dramatically in professional contexts. During a product development meeting at a technology firm, when an engineer discovered his approach wouldn't work, sensors detected no increase in stress hormones. Instead, his pupils dilated, indicating increased attention, and he immediately began exploring the failure's implications, leading to a breakthrough approach. He didn't need to manage his emotional response because his brain had automated a more productive response, notes Dr. Jensen. That's approximately 15% more cognitive resources available for problem-solving instead of emotion management. The seventh unconscious habit involves how intelligent people navigate information environments, specifically, how they unconsciously metacognate or think about their thinking. Jensen's team observed that high cognitive performers display what they termed representational shifting, the unconscious habit of translating information between different representational systems. In practice, this appears as a tendency to automatically convert verbal information into spatial arrangements, mathematical concepts into physical analogies, or abstract ideas into concrete scenarios. This habit manifests in subtle behaviors like gesture patterns when explaining concepts, the unconscious creation of spatial metaphors in speech, and distinctive eye movement patterns when processing information. The most flexible thinkers don't stay within a single representational system, explains cognitive scientist Dr. Thomas Rendell. Their brains habitually translate between different ways of encoding the same information, which dramatically increases their ability to detect patterns and solve problems. Neuroimaging studies support this observation. When processing complex information, the brains of highly intelligent subjects show increased connectivity between regions specialized for different types of cognition: visual, spatial, verbal, and mathematical. This enhanced neural integration appears to enable the automatic translation between representational systems. The eighth unconscious habit emerges in how intelligent people allocate their attention. specifically in their distinctive pattern of noticing anomalies. Jensen's team documented what they called background processing across various professional environments. We were studying something entirely different when we noticed this pattern, Dr. Jensen recalls. Highly intelligent subjects would consistently notice irregularities in their environments that had nothing to do with their conscious focus. This manifested as brief attention shifts toward unexpected environmental changes. A rearranged bookshelf, a slightly moved chair, a subtle change in office temperature. While these observations rarely reached conscious awareness or verbal expression, eye tracking and physiological measurements revealed consistent detection of and response to such changes. Further investigation revealed that this background processing correlated strongly with pattern recognition abilities and general fluid intelligence. The intelligent brain appears to continuously monitor its environment for prediction violations, things that don't match expected patterns, even while consciously focused elsewhere. This continuous background surveillance represents a massive parallel processing capability, explains computational neuroscientist Dr. James Lin. Most brains filter out irrelevant environmental data to focus attention. But the most intelligent brains process this information in parallel without compromising their primary attentional focus. This habit connects to evolutionary theories about intelligence development. In ancestral environments, the ability to detect subtle environmental changes, potential predators, food sources, or weather shifts, while maintaining focus on immediate tasks would have conferred significant survival advantages. Today, the same adaptive pattern allows for the detection of subtle social cues, environmental patterns, and information irregularities that others miss, often manifesting as what we colloquially call intuition, but is actually the product of extensive unconscious processing. The ninth and final habit on our list manifests in how intelligent people engage with disagreement and opposing viewpoints. Jensen's research team identified what they termed intellectual empathy as a distinctive unconscious response pattern when encountering perspectives that contradict one's own views. Unlike the common response of counterargument preparation, where people mentally rehearse their rebuttals while others are speaking, highly intelligent subjects displayed a neurological pattern associated with perspective-taking, the same brain regions activated when imagining oneself in another person's situation. They weren't agreeing with the opposing view, clarifies political psychologist Dr. Nathan Rhodes, who analyzed this data pattern. They were automatically simulating the cognitive framework that would make that view reasonable. It's a crucial distinction. They weren't abandoning critical thinking but enhancing it by temporarily adopting another cognitive position. This habit manifests behaviorally as a distinctive listening pattern. Decreased interruptions, information-seeking questions rather than challenging ones, and accurate paraphrasing before presenting counterarguments. Neurologically, this represents an automated form of cognitive empathy. While most people must consciously force themselves to consider opposing viewpoints fairly, the highly intelligent brain has developed neural shortcuts that make this perspective shifting nearly automatic. The result is more accurate mental models of complex issues and more effective persuasive capabilities. Intellectual empathy shouldn't be confused with agreement or conflict avoidance, emphasizes Dr. Rhodes. In fact, the subjects who showed the strongest neural signatures of this habit were often the most effective at identifying flaws in opposing arguments, precisely because they had temporarily inhabited the cognitive framework producing those arguments. These 9 unconscious habits, self-questioning, strategic confusion, organized chaos, curiosity gap creation, fluid recovery from interruption, the immediate pivot after failure, representational shifting, background anomaly processing, and intellectual empathy, form a constellation of behaviors that reveal intelligence in action rather than intelligence on display. But what do these findings mean for our understanding of intelligence itself? And how might they change our educational and professional systems? The implications are profound and far-reaching. First, they suggest that current intelligence testing captures only a fraction of cognitive capability, primarily measuring the conscious, performative aspects of intelligence rather than the automated habits that reveal cognitive efficiency. It's like trying to evaluate a car's performance by measuring only its top speed, argues educational psychologist Dr. Lisa Hernandez. You're missing critical factors like handling, fuel efficiency, and adaptability to different terrains. Similarly, traditional IQ tests miss the habituated cognitive processes that most strongly predict real-world success. This understanding challenges educational approaches focused exclusively on content knowledge and standardized testing. If intelligence manifests most powerfully through unconscious habits rather than conscious knowledge application, then education should prioritize the development of these cognitive patterns over mere information acquisition. Some forward-thinking schools have already begun incorporating these insights. The Westfield Academy in Boston has redesigned its curriculum around what they call cognitive habit formation. Rather than focusing exclusively on subject content, their teachers explicitly model and reinforce habits like self-questioning, representational shifting, and intellectual empathy. We're teaching students how to think, not just what to think, explains Principal Miranda Frost. The content is still there, but it's now the vehicle for developing these cognitive habits rather than the end goal itself. In professional contexts, these findings have begun influencing hiring and promotion practices. Some companies have moved beyond traditional interviews and credentials to incorporate observational assessments that look for these intelligence signaling habits. Technology firm Quantum Innovations has developed an assessment approach they call cognitive naturalism, observing candidates solving problems in natural environments rather than through standardized tests. Their hiring teams are trained to recognize the 9 unconscious habits that reveal intelligence. We found that traditional credentials and interview performance were poor predictors of on-the-job cognitive performance, explains HR Director Thomas Burton. By contrast, these unconscious habits correlate strongly with problem-solving capability, innovative thinking, and collaborative effectiveness. The research has implications for artificial intelligence development as well. As companies work to create more human-like AI, understanding these unconscious cognitive habits provides a roadmap for more sophisticated machine learning. Current AI systems can process information faster than humans and recognize some patterns more accurately, notes AI researcher Dr. Fiona Chong. But they lack these habituated cognitive processes that characterize human intelligence, particularly the ability to shift representational systems, create curiosity gaps, and practice intellectual empathy. Some AI researchers are now attempting to integrate these habits into neural network design, creating systems that automatically question their own conclusions, translate between representational frameworks, and simulate opposing viewpoints. On a personal level, understanding these intelligence-revealing habits raises an intriguing possibility. Can we deliberately cultivate these unconscious behaviors? The research suggests a qualified yes. These habits aren't innate talents but learned patterns that have become automated through repetition, explains neuroplasticity researcher Dr. Victor Mendez. While some people develop them naturally through environmental influences, others can deliberately practice these cognitive moves until they become unconscious habits. These habits reveal intelligence not as a static quality but as a dynamic process, a particular way of interacting with information and environments that has become so ingrained it operates beneath conscious awareness. Intelligence isn't something you have, concludes Dr. Jensen. It's something you do, repeatedly, consistently, until your brain does it automatically. The most profound implication may be personal. By recognizing these habits in ourselves and others, we gain a richer understanding of cognitive diversity. We begin to see intelligence not as a hierarchy with some people positioned above others, but as a diverse landscape of cognitive patterns, each with particular strengths and applications. Some individuals excel at representational shifting but struggle with intellectual empathy. Others display remarkable fluid recovery but less developed background processing. Understanding this cognitive diversity allows us to appreciate different forms of intelligence and to combine complementary cognitive strengths in collaborative contexts. For those who don't naturally display these habits, The research offers hope rather than limitation, the possibility of deliberately cultivating cognitive patterns that enhance intelligent functioning across multiple domains. The story of these 9 unconscious habits ultimately reveals intelligence not as something mysterious and inaccessible, but as a set of observable, learnable patterns of interaction with information, environments, and other minds. In that recognition lies both scientific insight and human possibility. The janitor solving mathematical equations on university blackboards, the barista executing complex sequences with unconscious precision, the engineer asking herself questions that break through cognitive barriers, all demonstrate intelligence not through what they know but through how they habitually think. And in those habits lies a more democratic, developmentally optimistic vision of human cognitive potential. As we continue to research and understand these unconscious patterns, we may discover that intelligence has always been hiding in plain sight, not in test scores or credentials, but in the subtle, habitual ways we navigate our information environments, recover from disruptions, question ourselves, shift between perspectives, and engage with the ideas of others. Perhaps true intelligence isn't what we know or even what we can figure out. It's how we habitually approach what we don't yet understand. In the unconscious habits that reveal our intelligence, we glimpse not just the measure of our minds but the potential of our species, our distinctive capacity to develop automated cognitive routines that continuously expand our understanding of ourselves and our world.